All right, so good everyone, and this is a follow-up class from last week, and today we're going to be doing more coding. So we were able to explain some of the technical terms the last time, and we saw the basics of fine-tuning. So this majorly the model fine-tuning aspects, and we've seen the basics, um, how we can load the data sets and actually pre-process the data sets. So we also checked out the dynamic padding, which is the method of pre-processing to enable us have an efficient model training and fine-tuning as well. So this week we are going to look more into the trainer class and how we can actually set it up and train the model efficiently. Then we're also going to see some of the arguments and most importantly, how we can evaluate the model to know how well it's doing. So without wasting time, let me just do a brief recap of all that was done last week. Okay, so give me minutes. So as I said last week, we actually did quite a lot. So give me minutes. Okay, so um, yes, and yeah, the things we just covered. I'll just quickly, we've done the model fine-tuning and we know that it is a technique used in transfer learning or is similar to transfer learning as the case may be. And with this, there are actually different ways you can do this. You can either use closed retrained models like that from the OpenAI. So the OpenAI is actually a closed retrained model. And that means that when you want to actually use their models, you might need some credits. So that's a paid model. Well, we're going to be making use of an open source model, which is the BERT. So the BERT is actually from the Hugging Face library. Hugging Face library, and Hugging Face is an open source library that provides us with a lot of models, such as BERT and even GPT-3. I mean, such as BERT and some other models that we can use. And in doing this, we have to process the data sets to match what is being expected by the model, and such as the removing of duplicates, the splitting of the data, the shuffling of the data. And one interesting aspect, as I said earlier, is the dynamic padding, which is a method we don't need to do by ourselves. We don't need to write it because we have it already in the as a class in this whereby we can just import it from the transformer class. So in the data collector. So these are interesting things we're going to look at today and see. So the overall aspect of it, after we process the data, the end goal is to feed it into the model so that the model can then train on it, then we evaluate it and see the results. So today we're going to dive into the code and let's go. So yeah, just some technical terms that we are using in the overall book. So you may hear me say some of these things. So just familiarize yourself when it's organized as a model, the data sets, the batches, truncating, padding, then bits, is the model we're going to be using. And it's from the Face library. Then the fine-tuning, which is the overall process of what we're doing. So okay, down to the code. So before we begin, first thing, since we're going to be going into the fine-tuning today, I will advise that you change your run type first to use a CPU, a GPU actually instance of Google Colab if you are going to be using Google Colab. So, but if you are going to be running it locally, you can set it up if you have a GPU enabled on your system. So I'm running it on Colab for so it should be a general. Okay, so it's being set up. So while it's being set up, the basic steps we're going to be running through is importing the data set, loading the data set from the Hugging Face library. So first, let's just import the basic libraries, which is Dodge. Then also, uh, there are also some other libraries we're going to be making use of, which they don't come by default with Google Colab. So we need to install them. So this will take some time. And after installing it, we have to restart the instance of Google Colab. Let's give it some time. I've actually done that before now, so it might go faster. So yours might just take at least 1 to 2 minutes. All right. Let's wait for that. So this actually what we're installing is the data sets. So this data set library comes from Office and it holds numerous data sets as I showed you last week. Let me just quickly do it. Let me just quickly show you. Okay. This is the data set library. You can check it out. So, uh, yes. All right. So the datasets library is hosted on Hugging Face, and Hugging Face has a lot of datasets which you can actually take as your own convenience and use it for training. And you have a model you want to train, you want to make use of this. So while it's loading, I don't know why it's loading slowly. Why I believe you can hear me. Okay, right. So if you look at this top aspects here, you will see the datasets. So this data set, we have a lot. We have define web. We have there are some common ones we use. So fine web. We have the glue. Then we have the this SMS. So a lot of these are here. You can just check them out and use it as you feel like. So there are no credits attached. So coming back to the model. So this is trend. This is loaded already. Then this accelerate function is a is actually an extra plugin that is going to is used to make training more efficient and faster. Then this evaluate also is also a method whereby we're going to use to evaluate our model. So all of these are what we're going to need in doing in fine tuning. So after that, we can then load the data sets. So we're going to import load data sets. So we've loaded it. So we're loading it from the hub. Then loading it, we don't need to do much. Hugging Face just provides the interface for us to load it from their API. And we're going to be making use of the Glue data set. So I mean the MRPC data set. So it's the Microsoft research purpose, which as I explained last week, it's 6 2 sentences and then says tells if one is a paraphrase of the other. So and if it is one is used to define whether it is and zero is used to define whether it's not. So we're loading it and it follows the glue guideline and therefore let's run this. And if you check it out, it's loading it and okay, let's give it some time. Now let's examine the data sets. If you look at it, it contains the train, the validation, and the test. So, and I said it's loaded from the space library. So with it in the sentence, we have the sentence, we have the label, and we have the index. And the train data set contains 3,668 rows. The validation contains 408 rows with the same sentence, a pair of sentence, and a label and an index. Then the paste also contains the same thing with 1,725 rows. So let's just quickly check this out. And if we check it out, we're going to see, oh, this is just the first sentence. And last week we evaluated that this actually is the is actually a paraphrase of it. So we checked out one that is not a paraphrase. So let me just okay. So this is not a paraphrase. So when we check it out, we're going to check. We say that the label here is zero. Showing this is not a paraphrase of the other. And there's a map function already uh, embedded in this that maps it out. So let's move on. Now for the trained data sets, we can check out the features. So these features will give us um, the data type of each of them. For the sentence, we already see that it is a string. Then the index is, sorry, the sentence two is also a string. Then the label, we've seen that it is being mapped as zero not equivalent and one equivalent. And let's move on. Then the index is of the type integer already, so we don't need to perform any processing on this as well. Okay, I think I have a chat. Okay, all right. So I will do that. Let me try to do that. Okay, give me a minute. Okay, so give me a minute. Let me just check it from the settings. Okay, too much. I think it should work. Yeah, so I believe it should work. Okay. So I believe you can see it clearly. Let's move on. And here we have the features, as I said, we have the features. Give me a minute. So, I'll just quickly adjust something. Okay, so let's continue. And we've done that already. Now, back to on the preprocessing of the data sets. Now, for us to preprocess the data sets, we make use of the auto tokenizer from the transformer class. So we have to import the library. So most of these are what we did last week, and we're still just continue from it. And we're using the checkpoints. This checkpoint uh, is from the Open Face library as well, and it is based on case. So we have several types. There's a based case, which is uh, a full model with the last class, as I explained last week. That we have this. If you look at CA, we have the classification end, then we have the foundation model, which can be based. So when it is case, it is combined with the classification head. Or we can actually remove that last layer and fit in what we want to train the model for what we need it for. So this uncased actually, can you still hear me? I don't know, it's not showing that my mic is working here. So if you can hear me, just signify. Just type it in the chat. So if you can hear me, just type it in the chat. I need
Can
to
hear
know.
you.
All right, thank you. From the tokenizer, we're taking this from the transformer and into the tokenizer. And for the checkpoints, so we pass in the checkpoints into the tokenizer. So it's a pre-trained model. And to test it, we can just pass in a single sentence and see how it goes. So let's just run this line of code. All right. So what it does is it's going to tokenize each of the sentences, and by tokenization, it splits it into um, subtext. So it can split a sentence into subtext and attach tokens, calling each of them tokens. That this model can use to allocate to map each of them, just like 1 being equals to A, 2 equals to B, 3 equals to C, something like that. So, but it has a different way of tokenizing it in terms of punctuation, in terms of other things like sentence can be divided into sentence and other things like that. So with that, then the input, we are going to pass in the sentence into it and check it out. So when we run this, you'll see that we have the input here, and it has actually done that and attached attention marks to it. So we can convert those tokens to IDs, and we can convert those IDs to tokens. That's it got. So when we convert them, we're going to see that each of these IDs that I gave out here are these tokens, which is from this sentence we passed into it. So this is a set. So even the comma as well and everything is being tokenized. Even the space is being tokenized as well. So we can define the function that does this, and when we define the function, so the function will take in a sentence, and the sentence is going to return the tokenized sentence using the tokenizer class. So it will take in a sentence, and which is an example, then pass in sentence one, sentence two, and we're going to be truncating it. Truncating means it has a default truncation value that we're going to be making use that is going to make use of. Then when we check it out, this line of code, what it actually does is the the function to the data set. So we're mapping this raw data set. The raw data set here is our data set here that we loaded from here. Let me show you. So this raw data set is what we loaded from here. So we're mapping this to the entire we're mapping the entire data set to the function. So it's more like a follow. So it's going to apply that to all of it. So it will take some time and to do that. So it has successfully mapped it. Now you can move on. And now we're going to go into the dynamic padding. So in dynamic padding, I explained that the dynamic padding takes in is a class in the is a process that batches each of these steps step by step. So instead of passing a default uh, a default truncation value or a default padding value, you allow it to go in step by step in the sense that for each batch, it passes to the longest sentence in that batch. And we can get this from the data collector with padding. So this does it for us with ease. And if we look at it, well, we can pass in just tokenizer into it. So with this, we've actually padded it already. And out. Then before we check it out, one more thing, what this line is doing is taking the tokenized sentence. Let me just bring it out for you. And it's taking the tokenized sentence, and we are actually taking just the index, the sentence one, and sentence two, which is all we need for the model to train. So the other aspects of it, we don't need it, which are these this aspect. If you look at it, we don't need the we need only the sentence one and index. So we don't need the labels. Okay. I mean, sorry, the other aspects we don't need. We need sentence one, we need sentence two, we need index. So we need label. So we're dropping every other thing within that, so that all we're going to be left with is index sentence one and then sentence two. So if you check it, so this is before applying the data collector, which is the with padding aspects. So we say that we have several lengths of sentences. We have 45, we have 60, we have 51, we have 47. So when we apply, by the time we apply this data collector to the samples, which is just these few samples we're going to use. So we'll say that batch, which is just a particular sample of what we need. Well, take it, we can find out that it's going to pad it to the size we need, which is 8 by 61. So what it does is that it takes it to 61, being the longest sentence here, and it pads it. So each of these sentences, it makes this one 61, it makes this one 61 as well. So when we check the shape, each of them is 8 by 61. And then we tried another example last week. If we take 0 to, let's just say, 7, 0 to 7. So, and when we check it out, we're going to see that we have 1, 2, 3, 4, 5, 6, 7. Okay, let's make it 0 to 8. Don't check it out. You see that the longest sentence here is 67. So what we should be expecting when we apply the data collector is that each of the shapes will be 8 by 67. So which is what it gave us. So with this, we can move on to fine-tuning the model. And to fine-tune it, we already have the tokenizer class already. So we've tokenized the data set. We've mapped it already to it from here to all of it. So I'll not rerun that again. And we've applied the transformation. So what we need to do is just to, we need now, what we're trying to do is we're going into the model training fully. So to go into the model training, we need to use the trainer argument. So this trainer argument is more of a it's more of a class that allows us to define some of the arguments that we need in training. So if you check it, let me just print this from the transformer. So in the trainer arguments, we can actually define all that we need, such as where we want to save the endpoints, that is the checkpoints during training. You can also define your scheduler. If you want to add a scheduler, you can define that. Then you can also define it. If you look at it now, for this now, what we just passed into it is the outputs. So the first argument there is the output, the output directory for the model, where you want to checkpoint it. And if you check the output directory here, you're going to see that it's the same thing as test, what to pass in test trainer. So there are so many arguments you can pass in here. There are just so many. You just need to take what you need. So you use CPU force. So if you set this as use CPU, it's going to force the training process to use a CPU, which we don't want that. Then save on each epoch. Save on. If you look at this, save on each. There's something else. Sorry. Save step 500. As it saves after 500 steps. So when you're saving this step, if you're setting save step, you have to set the save strategy to steps. So you can, there are some that go one with another. So you can't set this in isolation. You have to set it together. Then by default, seed is 42. Then by default also the save strategy is by steps. So you can adjust that to save by epoch. And there are a lot of things you can do. You can, the mark steps, the logging steps. So you can just go through the documentation. You can go through the documentation on the Hugging Face library and check out the trainer arguments and see those things that you feel will work best for your particular type of model. So for now, we don't need this. So I'm just going to set the model. And also, now for the model, we can define the model here. So in defining the model, we're using the auto model for sequence classification. So, and we're training from this checkpoint. So with this checkpoint, okay, let's just do this. Trying to, I'm trying to confirm we've not skipped a step. Oh, we only applied, let me see, we only applied this into a particular sentence. So, we can checkpoint, okay, and set. Let me see if we define that tokenized data sets. All right. So yeah, we are on track. We're on track. But once we check, let me check the tokenized data sets here. Okay, yeah. So we need to do one more step. So for our tokenized data sets, I told you we need, like these samples we need, we took in only this, we need only the index, we need syntax one, and we need sentence two. So we need to do this for everything. So we need to do this for everything. And if you check out our tokenized data set contains sentence one, sentence two, the label, the index, the input ID. This was what I was trying to check out the other time. Then the token type IDs and the attention marks. So we don't need the attention mask. We don't need the token type ID. So we don't need the input ID. All we need is just the index, the labels, sentence one. All we need is just the index, then sentence one and sentence two. The model is going to decide what the label is. Then it's going to check it with the validation. That's why we don't need this label. So the pre-trained model should be able to figure out what the label is, then cross-check with the validation before we test. So let's do this. Please. So we can find this by saying tokenized data set is equals to tokenized data sets. So we're going to be mapping it, and we want to remove the colons. So we want to remove what we're just doing is we'll take the tokenized data set and remove sentence one, sentence two, and the index. So then we do the same thing for the renaming. So the tokenized data set. Let's just check it so that we're on track. Okay, so on track. So we rename those columns now to, we're going to rename it to, so which is what we need. Also format it by setting it to the also to touch. So we can check it out. Let's see if we have an error. Oh, sorry. We've done this first step already. So we can just go to the other steps. Okay, fine. So with this, sorry. Okay. So we can check it out. Tokenize it. So when we check out the train, the column names. So what we just did is, these are what we're going to be passing into the model. So the tokens are what we're going to pass into the model, and we've already tokenized. So let me just do a brief recap. If you check it out, we converted this sentence to a token. So the sentence we converted to a token, we cannot pass in sentences into the model. The model will not understand the sentences. So we only need the tokens, which are what we're going to be passing into the model. So we tokenize it using the auto tokenizer from here. We use the auto tokenizer to tokenize it. Then after we tokenize it, we dropped the sentence which we can pass in. We dropped sentence one, we dropped sentence two, we dropped the ID. So we don't need that to repass. What we need is just the label. We need just the label. We need the input ID. We need the token type, and we need the attention mask. So we also had to rename the label to labels because we needed to match what what is expected from the pre-trained model as well. So that's why we have to rename it. As I said, in doing so, we just want it to align with what we have. So back to this, we have our tokenized data set already ready for the processing. So we can go ahead and I said where we start, we've defined our training argument. So the only thing we did was to set this the output directory where it's going to save. So we can go ahead and define our model. So for our model, I'm going to be using the auto model for sequence classification. So for the auto model sequence classification, which is what we're going to be making use of for this thing, we can run this. Oh, okay, we've not defined it. So we can define it. For us to define it, we can just we can import it. We've not imported. So we can say from, so we're going to be importing this from the transformer class as well. So most of us were importing from transformer. So the model, let me see, should work now. Should work. Should work. Okay, fine. It's working. So yes. So it's telling us some weights are not initialized. So that because while using the way it was trained is is actually normal for us to see that. So some of these things just need to get used. Then now we can go ahead and define the trainer. So what the trainer does is, in the trainer class, the trainer takes in everything that we are going to use in training, such as the model, the training arguments which we've defined. Then we already have our tokenized data sets, which is the training sets. We have the evaluation sets, Then we have the data collector. This data collector by default is going to be used by the trainer class. Then the tokenizer, which is the tokenizer we are using from here, which we defined auto tokenizer. So we see this, and we can go ahead and define that. So we've set it up. Now, upon setting up, the next step will be to train. So to train it, all we simply need to do is just to call trainer.train. So with trainer.train, we can train our model. So it's training. So while we're waiting for it, then what this is doing is we've been able to, let me just do a brief recap. We've been able to load the model, load the retrained model from the Hugging Face class, and we're using the bet on case. We've been able to load the data sets. We tokenize the data sets. So upon tokenizing, we process the data. We dropped the columns we are not making use of by using this. Then we also apply them dynamic padding to the model, to the data. So dynamic padding, then we also mapped the tokenized function by this. Then we defined our training arguments, and in our training arguments, we only defined this, which is the output directory. And from the model, we imported from the transformer, we imported the auto model for sequence classification. There are actually a lot of other types you can use. So you can check it, all of this on the Hugging Face library to know what you need. If it's sentiment analysis you want to do, you can check that out. There's if it's spam, not spam, more of classification. So this sequence classification can be used for when you also classify uh, binary classes, binary settings, that is one or zeros, just like in the case we have here. So, but when you want to, when what you're doing is more of a regression, then you can check out other models you can check the models you have here. If you check out the office class here, they have a lot of models that can be used. So if it's document answering questions, this is a multi-model. So what we are looking for is, yes, we're looking for is, this now is used for feature extraction, question answering, token classification. So text application, you can use it, you can check out some other increased listing. Sorry about that. So you can check out a lot of models and then check the one that fits for you. Asset as well, we have a lot. So the Hugging Face is actually a community whereby you can check and you can go ahead and make use of. So let's go back to our model and see. So this year preview is actually also one common data set that people use for review, spam or no spam, and the rest of it. So that's that. Okay, so it's actually an interesting aspect to check. So our model has finished training by now. So if you check it out, model actually did quite well. Let's evaluate it. So in 500, I said the default. Well, check that the default, it says it by steps, and the default is 500 step. So after every 500 step, it's going to evaluate. And the only evaluation here we have is the training loss. So if we check out the training loss, 0.55. So after the 500 steps, so it was actually videos in, so which shows that it was training well and it it did well. But let's see, let's try to evaluate it a bit. So we didn't define any evaluation strategy actually. So and we can just try to see if we can make some predictions on the validation class. So let's see predictions. Let's see. So we use it predict, we pass in the validation, and let's print it out so we can visualize it. So if you look at it, it's predicted and the shape of it is 400. If you want to check out the predictions, you can. And but the predict method actually is it uses only the metric. So the output of the predict method will give us the predictions, the labels, and the ID, as well as the metric. So we can define this again. Let's pass it out. So the predictions is going to be one thing about the prediction is that it gives the probability of a class and it gives the probability of that item. So we need to take in the logic and then get the IS. So with this, we can have, let's get this. Okay, before we do this, let's just pause. So the threads, which are the predictions, is going to be in P dots. So the predictions is actually the index, the I, which is the ID, the metric, and the prediction. So we want to take in the IS. So it's going to give it some probabilities. So we need the IS, which is why is argmax. Argmax. We pass in the predictions. Those predictions. Then the axis equals to -1, saying that we need the just the first one there. So this you can check out the grid. So you can go ahead and check out predictions with the labels, the actual labels. So all of these predictions are is going to give you in 1 or 0. So to fully evaluate it, you check out if it matches the label. So instead of doing this manually, we can actually bring up an evaluation strategy within the model training class. So what we do is we can import evaluates. So this evaluates comes as well with the it's part of the trainer class and it's also from the Ogniface library. We can use it to evaluate our model. So we can define our metric here. Let's just load. So we're going to compute this. Here, this predictions is equals to predictions. The reference is equals to this spread here. So the predictions are this, as we've seen. Then the reference is the prediction, which is the label of the actual label of the class. So if we check it, let's see, and let's use it to check it out. All right. So while it's checking, so if you look at it, uh, our model had an accuracy of 82, which is quite fine, and F1 score of 0.87. So this is actually very, very good. This is actually very good. So when you run this, it might actually vary, but it shows that the model is still fair, being that we didn't do much. So this is the advantage of using a pre-trained model to do everything we need. So summary of everything, you can also pass in a compute metric of so while it is running, as you saw in the last in this for the training argument, that you can use the print to print out the training argument for this. And in the training argument, you can decide to evaluate based on epoch. You can decide to you can check. You can also pass in your evaluation metric. So let's to wrap this up. Let's just define a complete metric that we're going to use to evaluate our model. So define a complete metric function. So to do this, what the complete metric we take in is going to take in the evaluation predictions, which are these. It's going to take in the predictions, which is this, something like this. After and it's going to do this all of this on the fly. That is in the process of training. Oh, I have a message here. Okay. Yes, I'll try to share the notebook. So I'm done. So, all right. So it's going to take in this compute. It's going to take in the evaluation prediction. Then it's going to use this evaluation, this evaluate that we imported here. It's going to just evaluate it and loading this, loading it directly from the Hugging Face library. Then the evaluation is going to bring in logic. So these logic are actually probabilities of the next. So it's like before the model predicts the next before the model is going to predict the probability of whether that particular sentence is a paraphrase of the other. So it's going to bring in probabilities like maybe 90% sure is 80% sure. So it's going to bring in several probabilities, which are the logits. So the logits is what is now going to take uh, the ag, that is the most probable one. So it's as if you have a probability of 10, 9, 8, 7 of a particular class. So for you, you're going to go with the highest, just like that. So you want to take in the highest, which is the hard max or the logits. And it's always you pass in the as to be -1. So then it's going to return the metric dot compute. So it's going to return all of this, which we did individually. So when we did metric dot compute, so we passed all of this individually. So we defined that, fine. So then we can now pass in all of this as one. So to pass all of this, we can do so let's just write this again. So training argument, yeah, the training argument is equals to the training argument. So we already have this. Now we're going to change our evaluation strategy. So once it's evaluated on each epoch, then the model as well. The model we're going to be using is the auto model for sequence classification. Then from pre-trained, and we're going to pass in our checkpoints, which we've defined, and the number of labels as well. We're going to pass in that. So the number of labels we have just two is a binary classifier, but the labels we have are 0 and 1, so it's 2. Then now we can also set up our training arguments. Okay, so our training arguments. You can find our trainer here. We don't need to set up much of the training argument. So the trainer will be equals to, oh, sorry. We've set up our training argument to the trainer. So this trainer class it actually makes things easy for us. So passing the model, passing the training tags, which we defined here already. Then we're passing the train data set. Why is it not to complete it for me? The train data set is equal to the tokenized data set already, which we already did. So we're bringing all of these things together, and which is a train. Then we're passing the evaluation data set as well, the data collector as well. So this data collector we pass in, then tokenizer. Now, one last thing we added is the compute matrix. So the compute matrix is this we have here already. So with this, we can go ahead and do that. So we've instantiated our trainer class already. So we successfully instantiated it. Then we can now go ahead and train. So we're going to trainer to train. Just so do that, we just need it to train the string. So this will take some time. To take some time, quite some time. So, but you are going to notice something that for each training, it's going to be evaluating it based on each epoch. So if you look at it, for each epoch, it's going to give us a training loss. Then it's going to give us a validation loss. Then it's also going to give us, let's see, did we miss something? Yeah, okay. Let's see. Yeah, don't worry, you will get it. Okay, I think we missed something. Let me see. One string. So it should give us the epoch, it should give us the training loss, it should give us the validation loss, and as well the accuracy and the F1 score. Because when we did this, metric plus compute gave us the accuracy and F1 score. And we've passed that already. So let's see. Okay, fine. Yes, it gave us this. So you look at it after each epoch, it's giving us the epoch, it's giving us the training loss. For the first training, there's no log, then the validation loss is this, then the accuracy 85. So you can actually use it to evaluate if it's training or not. So, and know when to stop and when not to stop. And it's also saving the checkpoint to this point. It's saving the checkpoint to this test trainer. So, which is fine. And eventually you can actually use the Hugging Face. You can leverage the Hugging Face architecture as well and send it directly to Hugging Face when you're training. So you can read up all of this in the Hugging Face library. So you can read all of this in the documentation. So now this training, you can see that we've achieved most of all we need to do to successfully train the model. So we've done that. We've renamed the sentences. We've checked it. So one other things you can do as well, you can also add a you can add a scheduler. You can add a scheduler as well to check it out. So a scheduler is what it does is for each training, once it does not meet a particular limit. Take for example, once your accuracy begins to drop, then the scheduler will get we alert the model and might stop the training. So there are different ways you can actually fine tune this. I think we're running out of time here. I don't know if I'm going to complete this. Fine. There's still some things we can do. So we can pass this into a Python loop that does all of this while it's training. So let's just hold on. There's nothing we can do for now. There's nothing we can do. We just need to wait. Wait. Oh, it is almost done. So, okay. Fine. We'll be done in no time now. Okay, fine. If you look at it, it's actually trained this, and we have a training loss of this. You said that the loss was actually decreasing. The validation as well, something went wrong. The validation loss increased, so it showed it was overfitting. The accuracy, yeah, the accuracy maintained the same thing. The F1 score, 89.4. So, all of this you can use to evaluate this. And you said that it also outputs a number of informations that we can use to check out our model. So, now all of these things we can put in a Python training loop and use it progressively to train our model. So to do this, we just need to set up a few things. We can set up the scheduler, and we can also set up an optimizer. So so for this lecture, let's just get an optimizer transformers. So we're going to be using an Adam W. So Adam W optimizer is more like is a better strategy to use. I just prefer it because it's leverage that's threshold. So it's more like an enhanced version of the Adam. So it's cut out for the weight regularization. So we're going to use this and preset the this it is taking the model parameters and also we're going to use the scheduler to from transformers. So let's import uh let's import the scheduler. So with this uh okay, let me see. Okay, let's use this. So for number of epochs, yeah. So number of training steps we're going to make use of. So all of this, we're going to pass all of this into the scheduler. By using a linear scheduler, the other ways you can set this up, if you check this scheduler library, let it load, give it a minute. So you can check it out and see some of the parameters you can define. So the scheduler type, the number of warm-up steps, the number of training steps. So the number of training steps, we've set it as this number of epochs times the length of the tokenized data set. So we can define this fine. Then so let's just print. So we're going to be passing this. Let's be passing this. So if you see the number of training steps we have here is quite large. 1,000, 11,004. Wow. Did we do that? Yes. Number of epochs. Excellent. Okay, let's use this. Let's just make it quite large. Let's use len of the train data loader. Then it's okay. So because next we're gonna define the trend data. Okay. So let's just define our data loader. So let's we also pass in distance. So sorry, time is not so much. So let's use from touch utils data import data loader. So this data loader is going to feed in this in batches. So our train data loader will be equals to data loader. So we're passing the tokenized and then our evaluation data loader as well. Okay, sorry. I want to correct some sense. So our train data loader is equals to data loader. We're going to pass in the tokenized I'm going to pass in the tokenized train set for the train. Our shuffle will be true. Yes. Our batch size will be 8. Then one more thing we're going to do is our collate function, which is a data collector. So the same thing we're going to do for the evaluation. So for the evaluation data loader, the same thing. So then if you look at it, we can by the time we check it for batch in train data loader, let's just check it out. If you check out the this thing, if you check out the shape of it, so once you check out key and value, it's actually a dictionary. So if you check it out, so you're going to see that it contains the labels, the input ID, the token size, and all of this. And because of the data collector, we have it in the same size. In the same size. If you're using TensorFlow, you might have an issue uh, with this data collector. If you're using actually a TPU, you might have an issue with this data collector. But for now, since we're using a GPU, so then we can pass this and reference this. This should work now. Okay, fine. So the number of training steps is now 1,377. So we can go ahead from here and set up our training group. So to fully set up our training group, we're going to be using PyTorch. I've already imported it already above, so let me just do it again. Then our device, type in PyTorch to use the GPU, use this line. So when you check it out, so device equals to touch the device, so LCP. So this ensures that does not run into an error in case there's no GPU enabled. So we run this, and then we see that we actually have CUDA based on the GPU we're using. Then, oh, yeah, we're going to use one more thing, CQTM library. This is actually for progress, to show our progress bar, to make it fine-tuned. Yeah, interesting. So in the progress bar, we're going to set our progress bar to be equals to CQDN. So the range we're going to be using is number of training loops, number of training. Yes. So we're going to set the training to model.train. So model.train actually allows you to go through a backward propagation steps in PyTorch. So if you don't set it to model.train, it's not going to train. So for epoch, so I will not go through the stress of typing all of this. You can just go through it. So for epoch and batch, then for batch in each of the data loader. So that is what it's saying is for each epoch. Then for the batch in each of the data loader that we set up here, the batch is a dictionary. So key, then the value to device, that is passing the data to the device, that is we're using a GPU. So you have to do this for each key value in batch.items. Then the output, I'm going to pass in everything in a batch to the model. So that's what this line does. Then the loss, we're going to keep track of the loss. send the loss backward. Then optimizers does step actually for each training, it steps for it the optimizer steps forward. Then the LR scheduler also as well, you step it. Then after for each, you need to set optimizer to 0 grad so that for each training, it does not it updates while you're updating the optimizer and the LR scheduler, you need to set it back to 0. If not, it will be accumulating. So you set up optimizer dot 0 grad, then you also update the training grad, the progress bar. So with all of this setup, we have our complete training done. So you can go ahead and train. So this will take quite a long time. Check it out. So we can go ahead and train. So you see that it gives us quite an interactive interface. So after I'm done. So in case you have questions, I don't know if there'll be time for questions, but that was all for today. While this is training, I will wait for the first epoch to train before we dismiss the class for today, because it's actually going to take you a lot of time. So in summary of everything, why this is training, all we just did is we loaded the data set, then we defined the checkpoints using based on case, and finally we preprocessed the data sets. We used a dynamic padding to pad it along for each batch. Then we also performed tokenization of the data using the auto tokenizer. Then one more thing, I think we've gone through everything. Then for the model training, we defined the trainer arguments. We pass it into the trainer class along the training data sets, the evaluation data sets. Then we defined our compute metric. Yeah, we defined our compute metric. Then we also defined the scheduler. Define the scheduler. Then we also use an optimizer, Adam W, to which is an enhanced version of the Adam, the normal Adam optimizer. Then we set our device to CUDA, and yeah, that's all. So with this, we covered quite a lot this class, and I hope you enjoy more training sessions, like you enjoy training other data sets along the way as you move on. So that's all for today. It's already on 93%. So almost done. It's already on the step function, is stepping it. So it's performing this loop for one epoch. So all of this is in one epoch. So it's done already. So you can actually evaluate the trainer, and that's that. So the training complete. So for you to evaluate, you can just define your evaluation loop and do that. So we may not be able to do that to be able. This is just a training loop. So if you want to evaluate, you just need to import the evaluate function. I don't know if I should go ahead with this. I hope I still have time. So I'll just quickly work on this. So for batch and batch and batch, it's touch. So then the logics here, uh, logics equals output logic, the prediction. Function equals to touch.add mass. So let's be using this. So the metric is add batch. Fine. So, and you can use this to compute it, and you'll see the evaluation. So you see that the accuracy is 0.82, then the F1 square is 0.88, which is very is okay. Um, Fine. So with this, we've done quite a lot. Then you can also use other things you can do is you can use the accelerate library. And this accelerate library increase efficiency of the training. So, and that will be the last thing I'll do for today. That will be the last thing I'll do for today. So, just need to modify a few things. Accelerate. We're going to import acceleration. And we just need to define our model as string. But let me just, okay, just need to do this again. Should I do it again? I'll optimize. We have our model already. So we define the accelerator will be equals to accelerator. So we have our model already. So we need to use the okay, we're going to use this. We're going to use the acceleration.ppa to do that. So string data loader, evaluation data loader. So this is the evaluation. We're going to pass in the model as well. Then the optimizer, which we already have. So let me just define the optimizer here again so that you don't mess it up. So all of this, we're going to pass into the accelerator as PPA. And define the optimizer here. So, yeah, that's fine. So we can just use 3 epochs, number of epochs. So 3. This 3. And now then number of training steps. So we've already set all of this before. Then LR scheduler. So we set all of this before, progress bar, then fine, we're good to go. So that's it, and that's all for today. So thank you everyone, and that's look at it. It's quite interesting journey. Training is and so fine tuning of a data of fine-tuning of an existing model to meet a particular need is all we've been able to do today. So that's all, and that's the end of today's class. Thank you.